All right, so today we're going to start with section 4.6. And if you have a book and want to follow along, that's going to be page 262. And we're going to be looking at special factoring, even more factoring. And there's a good chance that I can finish this early, and if so, we will move on to 7.3, okay? Try to get a little bit ahead. All right, so on page 262, we're going to start with problem number 3. And it looks like we're going to start today with factoring a standard trinomial. Nothing new. I think we've done this before. So, since this is a standard trinomial, we're going to start with parentheses, and then can you read the signs? Both plus. Both plus. Y and Y. Numbers. 9 times 9 is 81. 9 plus 9 is 18. And did anybody happen to notice this time that those factors are identical? And that means we can take one more step of simplification, and we can write that as y plus 9 squared. Now that is called a perfect square trinomial. Anytime a trinomial factors and the factors are identical, you can write it as a quantity squared. We call that a perfect square trinomial. And that's why it's in this section, special factoring. Any questions? Okay, number 9. And that is the way that looks in the book. And does anybody see maybe a problem with that? Okay, so it's not in descending order. So how about we start by rewriting it in the right order? So who comes first? Next? And then we don't have a choice. The next one is 81y. And now looking at those 3 terms, do they have anything in common? And don't forget that factor out has to come first. So if you have a common factor, you do have to take it out first. And then whatever's left over in the parentheses, you have to see if it'll factor again. And I don't know if you noticed, but it looks a whole lot like number 3. Yeah, so it's a standard trinomial. Can you read the signs? Yep, this time they're both minus. Y and Y, and the numbers? And is this another perfect square trinomial? So we can simplify that one more step, like so. Anybody have any questions about that one? Questions so far? All right, next problem, number 33. And does anybody recognize what that is? What is that called? Oh, you recognize it. Okay, what did you say? Who said it? Oh, I knew it came from over here somewhere. It's a binomial, okay? It's got a minus. And what do you notice about those 2 terms? Perfect what? Squared. So this is the difference of 2 squares, and we've encountered that before, I think. Do y'all remember the recipe for factoring the difference of squares? Well, I'll go through it again. The first ingredient is parentheses. Second ingredient, different signs. Difference of squares always has different signs. Third ingredient, fill in the blanks. Y and Y, 7 and 7. And then can I simplify that down and say why is something 7 squared? No, because the signs are not the same, right? They're not identical. And so that's as far as that goes. And that's factoring the difference of two squares. Anybody have any questions about that one? Anybody think we need to do another difference of squares, or is that pretty easy? I'm waiting for feedback. We don't need to do another one? Okay, we'll move on then. Next, number 53. And how many terms are there? And does anybody remember the technique for factoring 4 terms? Oh, there you go. Group them. Factor by grouping. Grouping. Factor by grouping. And so when we group them, we're going to group them 2 at a time. And then what can I factor out of the first group? What do they have in common? M how many? Squared, right? I can factor out M squared. And that's going to leave me with M minus 7. And now I have to factor something out of the second group so that it leaves me with M minus 7. And you do have to take negative 4. You do also have to take out the negative with the 4. So negative divided by negative leaves me a positive. And then positive 28 divided by negative 4 leaves me a negative 7. Everybody see how that works? Factoring out. Remember, when you factor out, it means you're dividing. And now we have the M minus 7s in common. So we're going to factor that out. And what does it leave me with? Yeah, and if you stop there, you get partial credit. Because M squared minus 4 is the difference of 2 squares. And that will factor again. Okay, so again, for the difference of squares, we always have different signs. M and M. 2 and 2. And that is factored completely. Yes, sir. Oh, man. You caught me, Aaron. I didn't do that to see if you were paying attention. I screwed up. Yeah. Yeah.
When you mark out the n minus 7, isn't that like squared thing or not?
No. And the reason it's not is because what I'm doing is I'm taking an M minus 7 from each of those terms. I'm factoring it out. So if I take this m minus 7 and I distribute it back in, it'll get me back where I started.
I see that.
So that's why this doesn't need a squared, is because I only need one of them to distribute back in. Anybody else have a question before I move on to the next one? Okay, next, number 77. And does anybody recognize what that is? What is it? Cubes? Okay. So specifically, this is the sum of two cubes. And so what three things make 8x to the third? 2x, 2x, and 2x, right? And what three things make 27? 3 times 3 times 3. And don't forget that you do need to write that stuff down because we're going to be grabbing it here in a minute when we factor. Okay, let's go through the recipe for sum and difference of cubes. First ingredient is parentheses. And don't forget that the second set of parentheses needs to be a little bit wider than the first, because for the second ingredient, we're going to throw in some soap. Y'all remember the soap? Same, opposite, always positive. Soap for the signs, right? And remember, soap is only for cubes and dirty people. All right, so the first sign is going to be same as the problem. Next sign has to be opposite of that. And the last one is always positive. Everybody see how the signs work? And that's the second step. Okay, third step, fill in the blanks. We're going to come up here. We're going to take a 2x and a 3. And that's going to give me the first two blanks. 2x and a 3. And then what we're going to do is we're going to take that first term, the 2x, and we're going to go 2x times 2x. Which is 4x squared. But I'll do it again. Watch. Bam. 2x times 2x gets me this one, right? And then watch this. Bam, bam. Those two. 6x. 2x times 3. 6x. Oh, last one. Bam, bam. 3 times 3. 9. And I'm done. Isn't that fun? Got it? Any questions about sum or difference of cubes?
How did you get the 9 again?
How did I get the 9 again? Bam, bam. 3 times 3. So to get these three blanks, you go bam, 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 bam.
Okay, do that one more time. I got the 4x squared. Now where'd you get the 6x?
Right here. Are you watching?
I'm watching.
Bam, bam, bam.
Okay, the 2x times 3 is 6x. Then
Right.
3 times 3 is 9.
Bam. Got it. Y'all see how freaking easy that is? If you get the first two blanks, you can't hardly miss the other three. Huh? It's not really just, no, it's just, it's like the technique, I guess. It's like math kung fu, right? That's dragon style or whatever. You gotta get the technique. Yeah, right. People tapping. I've got one more to do and then I'll be done with this section. Unless you have a request to do more, okay? But I've got one more that I need to go through. And that's number 91. There you go. And for number 91, first of all, can you tell me how many terms are there? 1, 2. Y'all see, terms are separated by plus or minus signs. So there's one term, there's two terms. Do those two terms have anything in common that I can factor out? Okay, I heard 5 and I heard x. Now, how many x's can I take? 2 of them? Because if you've got multiple variables, you can take the smallest power. And now let's see what we're left with. 5 divided by 5 leaves me a 1. X to the 5, take away 2 x's, leaves me x to the 3. Minus 40 divided by 5, z squared, but I took it away. I'm sorry, not z, x squared. X squared, I took it away, leaves me with z cubed. Everybody see how that works factoring out? And do y'all see that the stuff that's left over is the difference of 2 cubes? And that can factor again. All right, so let's write down what it takes to make each one. X to the 3rd, what is that? XXX, like the video store. And then what about 8z to the 3rd? 2z, 2z, and 2z. Everybody got that? And now it's time to do the recipe. First ingredient, parentheses. Second ingredient, throw in some soap. Same, opposite. Always positive. Everybody see how the signs work? Got to throw in some soap, right? Soap for the signs. Don't drop it. Okay, next. Third step, fill in the blanks. I need an x and I need a 2z. And then we're going to go bam, bam. X times x. And then we're going to go bam, bam. X times 2z. 2xz. And then last, bam, bam. 2z times 2z. 4z squared. And that's done. Let's rewrite that nicely. 5x squared, x minus 2z, x squared plus 2xz plus 4z squared. Man, factoring is fun. I love breaking it down. Anybody have any questions? How about this? Is there any item I covered that you need to see another example of? Another perfect square trinomial, difference of squares, sum or difference of cubes, anything you need another example of? No, you just feel pretty confident, huh? Well, I guess I'll move on then if y'all don't want to see it. All right, so we're going to add a piece of fish. And it looks like, according to the agenda, we need to move all the way to 7.3. We're going to take a giant leap forward to 7.3. And if you have a book, that's page 462. Did y'all make it? Page 462, 7.3. And I got to tell you, this section is complex, dude. Yeah, that's a math joke. This is complex numbers. Y'all familiar with complex numbers? You know, numbers that have the I in them, I for imaginary? Okay, so I'll give you the standard form first. A plus BI, and we call that standard form. That is the standard form of a complex number. And then just a couple of things that you need to know before we rock on. You need to know where I comes from. And I comes from the square root of -1. So anytime you run into square root of -1, you can replace that with I. That's where I comes from. And that's not bad grammar. Nobody caught that. Okay. Next, I squared. And that one is so important, we're going to put him in a box. Anytime you run into an I squared in a problem, you can substitute -1 in his place. I squared is -1. And at this point, we have enough information, we can do some examples. Starting with number 3. And the instructions say, express the number in terms of I. Express the number in terms of I. So what I'm going to do on this first example, I'm going to show a lot of detail, and then from there on out, I'm going to do a shortcut, okay? But the first thing, I want to show you how it works mathematically, and then we'll do it mathematically. So let's see if you agree with this. Would you agree that I can rewrite that radical expression like that? Does that mean the same thing? 25 times -1 is still -25, right? And then there is a property of radicals that says if you're multiplying numbers under a square root, you can split them up into their own square root. And that only works for multiplication. If you've got several factors under a square root, you can give them their own square root. And so now, can you tell me what is the square root of +25? 5. And what about the square root of -1? That's where I comes from. And so that's how we get complex numbers, numbers that have an imaginary part. Questions?
Is this needed in real life?
Yes. No, not really.
Does the I always have to be lowercase, or does it matter if it's uppercase?
That's a good question. In what we do in this class, the I needs to be lowercase. Because there may come a time later in another class where an uppercase I means something different, and so you need to keep them separate. Okay? So for what we're doing in here, the I needs to be a lowercase I. Once again, are there any questions about that? Go ahead, Kylie. Go ahead.
Why they gotta do imaginary numbers? Like, isn't math like super straightforward? Like, why they gotta like make stuff up to make stuff work? Right?
Like, why do we need imaginary numbers even?
Yeah. Why would we ever? Like, why do you need that? Like,
That sounds like a good research paper.
Does this carry on to like a different math?
I may have y'all write a research paper on this.
No.
Sorry.
Go ahead.
Does this only work if the square root is like 25 is 5, like if it was -7, it wouldn't work?
Yes, it does. It sure does. And so what we're going to do is we're going to do another example that will demonstrate that.
That would be easy to look at it and say 5i.
Yeah, but no, it works even if it's not square rootable. And the answer to the rest of y'all's questions about why do we even need this? You know, imaginary seems kind of kooky or not needed. And the bottom line is, well, you need to learn how to work with it, okay? If for no other reason than to just get through the class. But if you get on out there into other fields, it turns out that imaginary numbers are quite useful, especially in the field of electronics. Okay, so number 9. Now, did y'all hear me say that after number 3, from then on out, I'm going to use a shortcut, right? So here comes the math magic. It turns out that anytime you have a negative under a square root, you can simply bring it out from under the square root and it turns into an I. That's the shortcut. A negative under a square root comes out and turns into I. Do y'all see how that works? And then 98 does not square root nicely, but can I break it down? Can you give me 2 numbers that multiply to make 98, one of which will square root? Good. 49 and 2. 2 times 49 is 98. And the square root of 49 is? And so see, the 49 gets to come out, but I got to square root it. And so the final answer is 7i square root of 2. Now, how many of y'all have my calculator, the Casio? Okay, I would like you to try typing into the calculator square root of negative 98 and see if it gives you this answer. It does not?
It doesn't give you. It gives you an error code.
What did it give you, Liz?
7 square root 2i.
Oh, okay. Y'all's didn't work in the back, though?
Yep.
Did yours work?
Math error.
Well, do this for me. Hit mode 2. Mode 2 and then recalculate. No, it does, right? You know why that has to happen? Because mode 2 is complex mode, where we're doing complex numbers. Yeah, so now let's talk about why the calculator gives a different answer. Do y'all remember that I said standard form has to look like this? And do y'all see that in standard form, I is the very last thing you write? So what I can do is I can reorder these factors and I can put the I at the back. That's still a good answer. Do y'all understand that when I write the answer 7i square root of 2, all of those pieces are multiplied? And does it matter what order you multiply things in? Yes.
I still can't get it to work. What are you doing?
Do you have my calculator?
Yes, I have your calculator.
Let me come look. Let me give you some calculator counseling. No, it's the 115 ES Plus. Yeah, okay, so it turns out that there are some calculators that will not display complex numbers. And so that's why I recommend the exact model that I do. The Casio FX 115 ES plus. Some people see the Casio FX 300 and they think, oh, 300 is bigger than 115. It's got to be better. And it's not.
She got it, so I got it.
Yeah.
I copied her.
So it's like one of you decide to jump off the bridge, so everybody jumps off the bridge. Well, thank goodness we know how to do it by hand too, right? So it turns out that you don't need a calculator to do this. It's not necessary. It is kind of convenient, but it's not necessary. Let's do another one. Did I talk through that adequately? Do y'all understand that either one of these answers is correct? And the reason that I like to put the I in front of the square root is because if it's in front of the square root, I know for sure that it's not under the square root. And if you put it at the back and you get a little bit careless with your square root symbol, it might look like it goes underneath. But either one is fine. All right, let's do one more of those. How about? I'm going to make one up and you see if you can work it out. There you go. How about square root of negative 250? Let's see if you can simplify that radical. Okay, so that should be enough time. Let's cover the shortcut again. What about a negative under a square root? Do y'all see that? Did y'all notice also that that is the very first thing I do? Listen, the rules for simplifying radicals are the same as the rules for fighting. Right? First thing when you get in a fight, take out the i's. See that? First step, simplifying radicals, take out the I. And then 250, I think we can write that as 25 times 10. And then what is the square root of 25? So we're going to get 5i square root of 10. Or you can say 5 times square root of 10 I. Either one of those is acceptable. Anybody have any questions? Yes or no?
I got that answer.
You did?
Yeah, so like I simplified it to where the I was on the outside, and then I did the square root of 250, and it gave me the 5 and the 10, so I just put the 5 in front of the I.
So your calculator will break down the square roots.
Yes.
And all you got to do is make the I.
Yeah.
Easy. There you go. So you don't need another calculator. All right, let's do another one. How about number 15? This one's going to be different. Yeah, so for number 15, what they've done is they've given me a couple of complex numbers that already have the I in them, and they're going to want me to do an operation with complex numbers. Here the indicated operation is addition. Did y'all see that this first stuff in the parentheses, that is a complex number? The 12 is the A, and the 3 is the B. A plus BI. Do y'all see that? Complex number. Here's another one right here. And if I want to add complex numbers, all I have to do is combine like terms. So 12 plus negative 8. 12 plus negative 8. Yeah, I'm just adding like terms. So These are both A's. These are both A's. I'm sorry, they're both constants too. And then the 3 and the 5, those are both B's. And so then we can add those. And that's it. I mean, that's done. And if you want to do that on the Casio FX115 ES Plus, you can do that because there is a button for I. And you can actually type that into the calculator, using the I button. Everybody see the button that does the I? What is it? Is it the E and G button?
Yeah.
Yeah. And so you can just type this in with the parentheses and everything just the way it looks, and it'll spit out that answer for you. I don't know. That one's pretty easy just doing it by hand. You don't really need a calculator for that. But I mean, if you wanted to check, just to make sure, you could. Did it work? Okay, I got another one, number 23. And this time, what is the indicated operation? Subtraction. But did you notice that there is a minus in front of a set of parentheses? And so that minus is actually going to need to distribute. So that's going to give us 13 plus 9i minus 8 minus 2i. And then we can go through and we can combine like terms. 13 minus 8? How about 9i minus 2i? Seven I. 9 minus 2 is 7i. That's not too bad either, is it? Subtraction with complex numbers. I wonder if it gets any better. Oh yeah, number 45. Yeah, for this problem, you might be kind of happy you have a calculator that'll do it for you. Because this time, what is the indicated operation? Multiplication, yes. And I've got a binomial times a binomial. What does that mean? FOIL, right? Means I'm going to have to F it up. The 4-letter F word. We're going to have to FOIL it. Here we go. First, 8 times negative 2. Negative 16. On the outside, 8 times negative 5. Negative 40i. On the inside, negative times a negative makes 6i. And last but not least, negative times a negative makes 15i squared. Did y'all see that? I times I squared. Man, I'm glad I wrote that down in that box right there. What happens anytime you see an I squared show up? You can replace it with negative 1. All right, so let's combine like terms. I've got negative 40i plus 6i. What does that make? Negative 34i. And I squared gets replaced with negative 1. And did you notice that that is indicated multiplication? That's negative 1 times 15, which makes negative 15. And negative 16. And there's my final answer. Now, did anybody happen to type that into their calculator and see if it gives the same answer? You did? And it worked? Oh, yeah. Anybody have any questions about the FOIL method with complex numbers? Anybody? No? Okay. Let's see if I have anything else. Oh, I do. Number 65. Now, I'm not sure whether we've talked about it or not, but did y'all know that it's not okay to have a square root in the denominator? Have y'all ever heard that before, that you can't have a square root in the bottom of a fraction? Okay, well, it turns out that do y'all remember what I by itself stands for? Square root of -1. And that indicates that there is a square root on bottom. If you can't see it, but it's implied, right? Because that's what I represents. And so it turns out that you're not allowed to have I in the denominator. That's bad math etiquette. And so we're going to look at how do we get the I out of the bottom. Well, you don't just erase it, okay? Yeah, you have to do it legally. So to get rid of an I in the denominator, you're going to have to multiply by the complex conjugate. We're going to multiply by the complex conjugate. Man, that sounds sexy. Complex conjugate. And do y'all see what it is? It's the same denominator with an opposite sign. But whatever I do to the bottom, got to do to the top. So we're going to multiply top and bottom by 5 plus 11i. And the numerator is going to be the easiest one to do. All we have to do up top is distribute. And what's going to happen in the denominator? S again, right? The FOIL method. I can tell y'all are excited about that. Yeah, so let's F it up again. 5 times 5? 25. On the outside, plus 55i. On the inside, minus 55i. Last but not least, minus 121 I squared. Anybody have any questions about that step? Were you able to follow? Okay.
Yeah, but you just said earlier that they can't be squared denominator.
No, I said there can't be an I in the denominator. We're trying to get rid of the I in the denominator.
But the I equals -1 squared. Square root of it.
Okay, I by itself is square root of -1.
Square root, that's square.
Right. All right, so look what's going to happen to my 55 i's. What's going to happen to the 55 i's? Yeah, because it's plus and minus, they're going to cancel. And what can I replace I squared with? -1. And remember, that's a -1 times -121. And so the denominator is going to simplify to 25 plus 121. And we can add those and make what is that, 146? In the bottom, 146? And so my final answer is going to be 15 over 146 plus 33i over 146.
You can't just write it 15 plus 33i over 146. It's not the way it works.
Let me explain why not.
Separate it out.
You got to separate it out so that it's in standard form. So if we want our answer to be in standard form, you have to be able to see the A and the B separately. And so that's why we separate it out like that. So the 15 over 146, that's A. And the 33 over 146, that's B. And did anybody happen to try that one on the calculator? Giselle's shaking her head. Did you get this? Really? Wow. So the calculator bypassed all that work? That's kind of nice. Yes, sir.
I calculated to put the I on the outside.
Right. And that's fine. So you can put the I with the numerator, or you can put it out to the side.
Long as it's not in the bottom.
Long as it's not in the bottom, yeah. Because if it's out to the side, it's understood to go with the top. Thanks for asking, Brandon. That needed to be clarified, okay? Y'all understand that? If you stick a letter out to the side of a fraction, it's understood to go with the numerator, the top. Wow. Any questions so far? Is there anything else I need to cover about complex numbers? You think you got a handle on it, huh? Well, then what I'm going to do is I'm going to stop